So hi, I'm Wojtek. I work for Google in Android developer relations. I work mostly on Kotlin, but also on other things. And today I wanted to talk to you a little bit about APIs in Kotlin, APIs that we have in Jetpack, and explain a little bit about how we think about introducing Kotlin for Android at Google. So as you probably know, for the first time we announced that we're going to support Kotlin for Android, and we're going to support you in writing apps for Android and Kotlin 2 years ago at Google I/O. And that was in direct response to what developers really wanted. We've seen first people already using Kotlin. Many people were actually afraid to do it at first because it wasn't, let's say, blessed by Google. And we wanted to fix it. We saw the potential. We saw that people, that you developers, really wanted to have a modern, fun language to use. And so it happened. But you know, it wasn't just a thing that happened once. It was a journey, and that journey continues to till today. So I want to talk a little bit about how we look at it at Google. So you know, like I said, at Google I/O we said that we're going to support Kotlin on Android, but this decision wasn't made lightly or within one day, right? If we look in perspective into the Android platform since its very beginning, Kotlin was for the first time that we've added a new language to the platform in around 10 years. First we had the SDK with the Java programming language. Shortly after we introduced C and C++ support, and now Kotlin. And it took us a long time to get here. Why? Well, we didn't want to make any rash choices, to make any rash decisions, because this will influence the platform for the next 10 years. In fact, since we announced Kotlin as a supported language 2 years ago, this year at Google I/O we said even more. We said that increasingly in Android at Google, we will be looking at Android development as Kotlin-first. And we'll talk a little bit about what that means. So today I wanted to go quickly through what happened since the original announcement and what led to Android becoming Kotlin-first, as well as look into how development might look in a year, in 2 years. Before that, let's look at phase 0, the original announcement. So what that really meant for us at Google was that we promised you to not break things, or at least try to not break them. And our phase 0 for introducing Kotlin for something like Android probably looks a little bit different than introducing Kotlin at a company that you work on. First of all, it's kind of similar. We had to assess the technology, we had to convince the executives, we had to get buy-in from people higher up. And then the base thing, we bundled the Kotlin plugin in Android Studio and promised that we will try to make the next versions compatible with each and every new release of Android Studio. There was a lot of work that was done on the IDE side and tools side to support things like lint checks, refactoring, basically to give you the best developer experience with Kotlin that's possible. And then a lot of work was actually on my team, on developer relations. So we had to produce all the documentation in Kotlin, sample code, new videos, basically teach developers who want to get into the language to start using it on Android. And then, of course, there was a lot of work to do internally for teams at Google to actually start learning Kotlin. I remember myself when we originally announced Kotlin as a supported language, I couldn't call myself an expert. I was just starting with Kotlin, just like probably many of you. And so it took a lot of work. Now, phase 0 at your companies might look a little bit different. First of all, yes, you have to assess the technology. Is it right for you? You have to get buy-in from team leads, from executives probably. You also have to get buy-in from your teams, right? Even if you're the one person on your team who really likes Kotlin and you want to introduce Kotlin for all your APIs, that doesn't mean that everyone will jump super happily into adopting Kotlin from day 0. And so you probably need to have a way to train the team to make sure that everyone feels included in this decision. Agree on things like tools that you will use, style guidelines, things like that. And finally, comes the moment where you start adding Kotlin to your code base. And I'm wondering, how many of you are still in this phase 0, where you want to use Kotlin in your apps, but you're maybe for reasons not using it yet? Any people here? Okay, if you see a few hands. So I get that everyone else is using Kotlin already. That's great. But that's actually, we're here in DroidCon New York. And yes, Kotlin adoption is really high in the US, in Europe. Actually, there are parts of the world where Kotlin adoption is, I would say, lagging. And a lot of the people I talk about at conferences come to me and say, how do I start getting into Kotlin? How do I start learning it? So, that's why I'm talking about these things like setting up a training program and so on. We can't take these things for granted. Okay, but then let's say you're all set. You have the green light. You're starting Kotlin to your app. Your app is legacy code. Probably you have a lot of Java modules still, and suddenly Kotlin looks great, but you need to start calling these Java APIs, and they all look terrible. Like you want to use lambdas, you want to use all the nice thing that Kotlin gives you. And so we're at phase 1. We still have to deal with Java code that we cannot change. And actually for Android, this is a big thing, right? Because the Android SDK has been built up over 10 years. It's not like we're going to go and rewrite it in Kotlin. And that's why, even 2 years ago, when we first announced Kotlin support, we started this KDX project. And the classic example, very simple thing, making our APIs nicer to work with from Kotlin on the example of shared preferences. With a simple extension function, we can reduce the boilerplate, we can make this a much nicer to use from Kotlin. But this is all actually syntactic sugar, right? This doesn't give you any new functionality. This is nothing you get from Kotlin that you couldn't do from Java. It literally reduces the code you would write to write the same thing. But the thing I want to show you is, this is all possible because of the language features that are built into Kotlin. Even this simple example shows you already extension functions, lambda syntax. This lambda is even an extension lambda, right? So it has a receiver of a type of shared preferences editor. And that as the only and last argument, you can use the shorthand lambda syntax, like on the previous slide, to pass the lambda in the brackets after the call. So even in this simple example, we're already seeing the powerful features of Kotlin that let us introduce this new syntax, these new features to older APIs that maybe we cannot change. Some of these things that I want to highlight that to inspire you to build your own KTX functions, maybe for your legacy code bases, to make it easier to work from Kotlin, are of course extension functions. Probably the first thing people mention when they talk about Kotlin. There's operator overloads, there's type-safe builders or DSLs, and property delegates. And I've shown the very simple example of shared preferences, but we actually have examples of all of that in our KTX library now in Jetpack. So if you go into our documentation, if you go into the libraries themselves, you will see examples like this, just making our APIs a little bit nicer by adding some new operators. Like in the preferences library and Android X, we take we can benefit from overloading the get operator, introducing this nice bracket syntax to access preferences that are that are stored in our preferences tree. We can assign new preferences using the plus operator. We have DSLs for building your navigation graph. So this is something you can do normally from XML. You can do it programmatically in Java, but we also have this nice DSL syntax where you can build everything in a declarative way straight from your Kotlin code. We have custom property delegates that let you do things that would require boilerplate code for every time that you want to access it in every activity, in every fragment. Here an example, getting arguments for your navigation graph from the navigation library. So we have a lot of these things in our libraries already. How do you find it? How do you access it? Well, it's not always easy. You have to know that they're there. We're looking into ways to make this more discoverable. However, we did one thing. If you haven't noticed, recently we changed all of our reference docs by adding this switcher on the top right between Kotlin and Java. And now you can have a Kotlin view on all of our Android SDK and Android X libraries that actually lets you see all of the extension functions that are in the package, that are on the class, straight from documentation. So go and explore, find the KTX functions that you will use in your own programs, and let us know how we can add more. Okay, so you've started adding KDX functions to make your Java libraries play nicer with Kotlin, but you will also continue writing libraries that other people will use, either as modules in your projects or something that you put on GitHub that you want other people to use. But you're not ready to make the jump. You're not going to write them in Kotlin. You still have to write them in Java. Not all developers are ready to consume, only Kotlin libraries. Maybe they don't include Kotlin in their build. How can you make sure that what you write in Java is actually nice to use by someone who is already using Kotlin? There's this term that we use called Kotlin friendliness, and we encourage developers to make their libraries more Kotlin friendly. And some examples, like, of course, the most simple way, use the nullability annotations on your Java code. Now, this not only benefits Kotlin users, but Java users as well. Makes your libraries a little bit safer to use. Remember about adding nullability to your parameters, to your return values. When you think about methods that take something like a callback, always remember to put it last. So in Kotlin, you can use a lambda. You can use the shorthand lambda notation. Remember to not use hard keywords in Kotlin, such as in. Now, we've had this problem in some of our testing libraries, for example. Every time you had to use a method that was called in, you had to put it in backticks in Kotlin. That wasn't very nice. So remember not to do that. And finally, remember to benefit from the property access syntax in Kotlin by naming your getters and setters properly. Now, these all seem very simple, but also easy to forget. That's why in Android Studio, there's actually a lint check that not many people know about. If you're making libraries, if you're making modules that will be consumed, Java modules that will be consumed from Kotlin, be sure to go into inspections and actually enable this one, which is not enabled by default. And it checks for all these interoperability problems for Java libraries with Kotlin through the lint mechanism. Please do that. Please make sure that you produce code that's nicely consumable from Kotlin. So how does that apply to our SDKs? So like I said, it's not easy changing our framework, but we can do things. And actually, since the Android Pie SDK came out last year, we started adding nullability annotations on all new APIs. Now the problem is, with 10 years, it's a challenge to go back and annotate everything. So unfortunately, you will still see these platform types for many of the APIs in the Android SDK. However, we have made a promise to build all new APIs thinking about these things that I just mentioned, to make them more Kotlin friendly. And obviously, it's easier in Jetpack, which is unbundled from the platform. We can make sure that whatever we build is Kotlin friendly by default. Okay, so we started adding Kotlin. We started adding extension functions to make our syntax nicer when using our Java functions from Kotlin. And we also make sure that our Java interfaces look nice from the Kotlin side. But we would like to get more. Kotlin is more than just syntactic sugar, than just extension functions that we can apply on top of existing Java APIs. And so here, I think we recently entered this, what I call phase 3, where when using our libraries from Kotlin, you actually get more. You get things that you would not get otherwise if you were using Java. And here I'm mostly talking about coroutines. Now, recently we introduced a lot of new Jetpack libraries or Jetpack integrations with Kotlin. And let me just talk you through some of them here. For view models, we added a new coroutine scope. So how many of you embraced coroutines as a way to run async code on Android? People are starting to use it. Now, we at Android, we at Developer Relations think coroutines are great. And we want to make all of our APIs work really well with coroutines and give you developers the best tools to do that. That's why we're adding things like the extensions on view models, so you can get a view model scope that gets canceled and cleared when the view model goes out of scope, and will cancel your coroutines. We've added lifecycle aware coroutine scopes on other parts of the frameworks as well. So on activities, on fragments, get scopes where you can run your coroutines for specific parts of the activity lifecycle or the fragment lifecycle, and not care about having to cancel or stop your work whenever some of these conditions are not met. For things like Work Manager, we've added a special coroutine worker that that benefits from probably one of the best things about coroutines, which is cancellation. Previously, when you were submitting jobs to a Work Manager, you had to take care to cancel these jobs whenever you got a callback from the Work Manager. Now with coroutines, because coroutines are cancelable by default, you get that more or less for free. For things like Room, of course, we've had integrations for RxJava, for other types of observables and listenable futures, but that's all. That's still a lot of boilerplate. That's still pure Java. Now with Kotlin, with something like coroutines, with the suspend keyword, we can actually expose a function that will read stuff from your database that when you call it, you don't have to worry about blocking the main thread. If you call it from a coroutine, we do the heavy lifting for you. We suspend the work whenever you read something from disk, and then we get you back the results, all in a main safe manner. And when I say main safe, this is actually a way we encourage people to write your coroutines code. So whenever you think about making a suspend function that someone will be consuming from their own code, don't push the responsibility of running it on the right dispatcher, running on the right thread, on the user. Think about making your suspend functions main safe. By using something like this, if you know you're going to be doing I/O blocking operations, do them on the I/O dispatcher. Expose the suspend function that's already pre-configured to be main safe, so that when someone launches a coroutine from something like a vModel scope, from something like an activity, a fragment, they will be sure to not block the main thread. Actually, my colleague Sean, who just had a talk today on the other stage, wrote a great three-parter series of articles about coroutines, explaining a lot of this stuff about being main safe, about cancellation, about how to think about even constructing coroutines from your app, and which scope to run them on. If you're not following our Android developers on Medium publication, I really encourage you to go and try it and read it. There's a lot of stuff from me and my colleagues about both introductory and advanced topics related to Kotlin and coroutines. Okay, so, coroutines is one thing. This is just one of the new features in Kotlin that really is a big break from Java. This is something that did not exist in the other language. But we're obviously doing more. And with time, you will see more and more integrations coming together with Kotlin APIs, working better with Jetpack. One of the examples is the SafeArcs plugin for navigation can now generate Kotlin-only code. So if you're moving your app to Kotlin, if you're leaving Java behind, you can start switching to this Kotlin version of that library. And we're probably going to see more of that in the future. Okay, so phase 4. Like I said, we're going increasingly Kotlin-first. You will see libraries that maybe are written in Kotlin only. Does that mean we're dropping Java? No. When we announced that we're going Kotlin-first at Google I/O this year, we also told developers, we do not intend to stop supporting your existing apps, your existing code in the Java programming language. The knowledge, the code bases that you built up over the years, we're not asking you to throw everything away. We're not asking you to rewrite everything you have in Kotlin. However, Kotlin libraries will be popping up from third parties, from the community, from us as well. Maybe the next big Jetpack component will be written in Kotlin. Who knows? Does that mean we're telling you can't use it from Java? No. But you will probably increasingly see ugly code like this. So, companion classes. Kotlin doesn't have static functions, right? If you do nothing and you try to call it from Java, it'll look like that. Top-level functions or package-level functions that are defined as at the top level in a Kotlin file. If you try to call them from Java, you will see this file name at the beginning, right? And it's not great. It doesn't look good. What's this KT thing over there? And if you like to use things from Kotlin like default parameter values, and then you have a function that has 10 of these. But in Kotlin, it's nice. I can specify just one, and I don't have to put nulls everywhere. If you do that from Java, and you don't think about it, if you don't provide that that nicer interface from Kotlin to Java, you will see ugly code like this. So what can you do? There's actually a really, really nice page on kotlinlang.org on the JetBrains website, going through all of these annotations that can help make your Kotlin code Java friendly. So see, we're going the other way now, right? We're trying to make our code idiomatic Kotlin, the best to use from Kotlin, not forgetting about our legacy Java users. So a couple of examples, the ones that I showed you on the previous slide, companion objects that have something like static methods, file names instead of class names, and methods with default parameters. You can use some of these or all of these to help you with the JVM name annotations on your file, on your Kotlin file. You can make that into a nicer textutils class instead of this textutils KT. You can even split all of your utils methods across many Kotlin files and then use multi-file class to bring them all together into one named class so that it looks nice from Java. You can generate Java fields for your properties instead of this get and set syntax. You can generate static methods for your companion object properties. You can even assign a different name for a function in Java if it makes sense, if it makes better sense than your Kotlin name. JVM overloads is actually pretty important. This is something that I'm actually surprised this is not on by default. So again, if you have a lot of parameter values, default parameter values in your Kotlin method, if you add this annotation, the compiler will generate all of the versions of the call you can make from Java with the defaults filled in. So you don't have to put all these nulls at the end. Of course, you're still not able to fully use like named parameters from Java if you have them in Kotlin, but at least at least you can call the easy version of the method with some of the parameters filled in. And finally, throws. You probably all know that Kotlin doesn't have the concept of checked exceptions. And this is a big mismatch with Java, right? So if you throw an exception from your code in Kotlin, if you don't add the throws annotation, the Java side will not know, someone consuming your API from the Java side will not know that they need to actually check for something like an IO exception, illegal state exception, whatever. So you can use that. So this is all great. Kotlin gives us all these nice things to make our lives easier, to make our apps safer through things like nullability annotations and lambdas and nicer syntax. But a lot of the developers that I talk to at conferences like this one come and ask me, okay, I want to add Kotlin, I'm sold, it looks great, I love it, but what's the performance impact? Will it make my app slower? My answer usually is probably not noticeably. It's not like you're running, for loops that run 1,000 times on every frame of your app. But there are things we can do to make it even better. So even outside of, something visible to developers outside of Jetpack, going deeper into compilers, optimization tools, and our IDE, we have teams working on making Kotlin the best language to use on Android. And in fact, the R8 team, R8 is now our default Dexter and optimizer in Android Studio. The R8 team are working closely with the compilers team on Kotlin-specific optimizations to make sure that your code can still take advantage of all these features like nullability annotations and not be slower on Android. So let's look at an example here. We have a simple Kotlin method. It takes 2 parameters. Notice that they don't have the question mark at the end, which means, of course, that they're non-nullable, that they're not null. This is how your function looks like after you compile it with the Kotlin compiler with this pseudo bytecode. This is what gets inserted right at the beginning of your method. First, we allocate a string, that's the parameter name, and then we invoke a method, a separate method from your own, to check if the parameter is not null. And we do that for every parameter to make sure that it's not null. And only then we run your method code, right? Now that's not optimal. Why would I want to allocate strings and call separate methods that go somewhere else, execute some more code just to check nulls, if most of the time the compiler already checked that, right? The compiler would not let me compile my Kotlin code if the null checks were not in place. So can we optimize that? So the R8 team went and built specific Kotlin optimizations where they invert that logic. What they insert at the beginning is a simple if equals check to only move control of the program to these allocations and separate method calls if your parameters are null. Most of the time, we only go through these simple if checks, execute your method, and return. That makes it a little bit faster, a little bit more optimal for every method in your program that has these nullability checks. Another example, lambdas. Like, a lot of people are really worried about putting lambdas everywhere in their programs. And I just told you that we're actually making our APIs in a way that promote using lambdas because it's nice. They're easier to use. We don't have to subclass a lot of observers, callbacks, and so on. The thing is, every time you then create a lambda with certain parameters or with capturing certain variables from outside the lambda scope, what the compiler does, it creates a separate class for every lambda that you create. What can we do with that? Or in order to optimize it a little bit, we can go back and merge all of these classes that are compatible, which by compatible I mean they have similar captures, they take similar arguments with them into the lambda scope. And R8 can go and merge all of these generated lambdas into one lambda class. So, a lot less classes, constructors, methods. And inside that, there's something like this. Now, this is not exact code that's being generated, but there's a switch that basically looks at which lambda am I looking at for this particular part of your program. It goes into a switch method, finds that lambda, executes it, done. A lot less space used in your APKs, a lot less method references, and so on. So these are just some of the things that we're making to make sure that you can feel you can use Kotlin safely without compromising on speed, performance of your apps. Now, so yeah, please use R8. Now, like I said, this is the default Dexter and optimizer. However, I know that many people go and disable R8 or disable minification at all for your apps. Now you're losing out on all of these benefits if you do that. And there's actually one huge benefit that I want to tell you about today. It's something that I've been working on for the past few weeks. There's actually a problem with dispatcher's main that you will all use if you use coroutines in your app. And as you saw, we're probably going to be using coroutines quite a lot in the nearest future. Now the problem is that on Android, there's a Java API that's really slow, and that's service loader. Now, Kotlin coroutines use service loader to load the implementation of the main dispatcher, the one that runs the dispatches on your main UI thread. It uses the service loader pattern, and it's super slow on Android. Moreover, it can block on disk. It always blocks on disk I/O, which can take like hundreds of milliseconds. But fortunately, our teams and JetBrains teams noticed that. We talked to each other and we thought, okay, we need to fix it, right? So the proposed solution was to re-implement the service loader as something faster on Android, or to just optimize it in R8. Okay, so the solution, Kotlin X coroutines now uses fast service loader, which is a faster implementation, which is great. It's faster on Android. The problem is it still blocks on disk I/O. It still reads something from disk in order to initialize your dispatcher's main. So whenever, for the first time, you want to access it, your app will freeze. You will see jank. You will see strict node violations. Now the problem too, the R8 team also thought it's a good idea to optimize it, and they went and implemented a specific optimization for service loader. The problem is now Kotlin coroutines is not using service loader, it's using fast service loader. So we kind of diverged here for a bit and did two different things. Things didn't work well together. What can we do? We started talking to each other again. We implemented fixes in coroutines that actually can let you bring back the old slow service loader implementation And together with the optimization we're doing in R8, we can do away completely with disk access, with disk I/O on main thread, and optimize away the service loader calls. Now, this is all still in early stages, although it's coming together nicely. If you're on Android Studio 3.5, which uses the proper R8 version, if you use the newest coroutines releases, which are not stable yet, but they're in release candidate, so you need to be on 1.3.0, and if you add this line to your R8 config, we will do the optimization. We will do away with disk reads. Your dispatcher's main should be fast again. Now, why is this the almost final solution? Because it still needs action from you, the developers. And we know that not all of you will remember to do it. Not everyone will see this presentation and go and add this to their config. So what we're doing is in Android Studio 3.6, and together with the newest coroutines version, we are making this automatic, as long as you don't disable R8. Actually, if I'm not mistaken, the first version of Android Studio that supports it is coming out today. So please try Canary 8 when it comes out. Upgrade to the newest coroutines version, and you should not see any freezes the first time you use dispatcher's main. And if you find any problems, please submit bugs on bandroid.com. This is super important. We can fix them while Android Studio is still in Canary or in beta, and we really rely on your feedback and to let us know maybe why you're disabling R8 if you have any problems with it. The team is super responsive. They really want to make your experience with Kotlin and with R8 the best possible. But you have to speak up if something's not working for you. All right, so what's next? I told you about how we introduced the Kotlin from the beginning with the simple tricks that make our APIs a little bit nicer. I told you that we're now actually adding stuff to Android X, to Jetpack, that gives you more functionality from Kotlin than if you're still just using Java. What's next? You probably all heard about this thing called Compose, Jetpack Compose. We announced it as an experimental project at I/O this year. This has the chance of being the first library that we actually make for you in Jetpack that will be Kotlin only. So, we had to. It took us 2 years to come to this moment where we announced that we'll be going increasingly Kotlin-first. And we really don't want to shut everyone out from using our APIs. And many of the Jetpack libraries, like I said, will be Java-friendly, but maybe Kotlin-first. This is probably the first time where you actually need to use Kotlin to access something. It's an unbundled UI library, and it relies on a custom Kotlin compiler plugin, so it will not work without Kotlin in that way. To work. I will not get into details. This is still very experimental. I'm sure you will hear a lot more about Compose in the coming months. In short, it's a new way to do UI on Android. After 10 years of the same view system baked into the framework that we could do nothing about, now we will have an unbundled library, compiler plugin that will enable this declarative syntax working together with a Kotlin compiler to make working with UIs a lot better. Now, if you're interested to learn more about this, there was a talk at I/O this year, and stay tuned, of course, for Android Dev Summit this year, where you will hear a lot more about Compose. What's next? else than Compose? You probably see that at this conference, probably over half of the talks are about Kotlin. And of those, probably half of them are about things like coroutines and something I didn't mention in this presentation, which is Kotlin multi-platform. And of course, we're going to be looking at more coroutines integrations. There's this new thing called Flow that just became stable for the first time in the newest coroutines version. We're, of course, looking very closely into everything that's coming out, both in new language features and new libraries. The thing is, just like with the original introduction of Kotlin on Android, we want to make sure that whatever we tell you to use, whatever we adopt in our libraries, that makes sense on Android. And something like Flow probably makes sense, but we need time to find the right ways of integrating it. Maybe with something like Room for database updates, maybe with something like Live Data for bringing data from lower layers of your app back into your UI. So give us more time, and for sure we'll see more of that. As far as multi-platform goes, we're not ignoring it. At the same time, I think we're at this phase 0 right now, where we will see developers slowly start to experiment with that. We'll see the need in the community to actually have more opinionated views on how to use multi-platform with Android apps, how to share your code base with something like iOS or the backend. And when it's time, when it becomes stable, maybe next year at droidCon New York or maybe at other conferences, we'll probably hear more about it. For me, myself, I'm looking at it very closely, and I think it's super exciting. It's the first time I actually believe in something like a cross-platform solution using Kotlin multi-platform, but it'll take time. I think right now we need to focus on developer experience still, even after 2 years, making our SDKs even more Kotlin friendly. And especially one thing that we're hearing very loudly from developers, and we're working on it very hard, is build speeds. So annotation processing, compiler speed, we're all working on that. In fact, together with JetBrains, we made some of the most popular annotation processors, including the ones used from Capt, the Kotlin annotation processors, incremental in the latest versions of Android Studio. So we're listening to your feedback. I'm curious to hear if there's anything else you need other than the things I discussed, the things I mentioned, that we could give you as Android developers to use Kotlin in your apps. So please do find me after my talk. We might have time for 1 or 2 questions, and that's it for me. Thank you.